Okay, so thanks for having me here today. I will speak about one of the things that we need to do to use software in a safety context, which is static analysis. Only the part of static analysis is what concerns the presentation of today. So let me see if this works. Yes. First, a disclaimer. I am a member of the MISRA working group and of the MISRA software quality metrics working groups. I'll also represent Italy in the C standardization working group, but I am speaking here today in a personal capacity. So let's start with some introduction. Static analysis is often perceived as slow, noisy, and also it enters into the picture later. So when much of the software has been developed already, and this is especially true for open source software, meaning for open source software that becomes famous well after, and that whose development was started many years ago. So in many cases, when we talk about open source software, well, the things that we need to do to safety qualify the software are done later. And this is a problem for the adoption of open source software because the safety and security standards require us to do certain things and to provide evidence about the activities performed, and this include static analysis. So the thesis of this presentation is that the adoption of continuous integration and static analysis embedded into continuous integration can improve the code quality and produce the audit evidence at the same time. And there are a few ingredients for this. So one is the tailored guidelines, yellow flag deviation, and the incremental and baseline aware of analysis. And of course, we need tooling that supports all of those things. And the desired result is to make source code analysis a merge gate and hopefully keep the contributors happy and build the evidence automatically. So why static analysis and why now? So static analysis, as you all know, has the big advantage of early defect removal. It's one of the more productive ways to remove defects from software together with peer review. And it allows us to achieve quality by reducing the reviewer load and drift. Okay, this is especially important in open source projects where maintainers are typically overloaded and they need to decide whether to accept a change or not. And if done properly, every run is repeatable and produces the needed artifacts. And if done properly, it can be developer friendly. So it can be set up in a way that does not disrupt too much the work of contributors. And why now? Well, for several reasons, and including the emergence of the CRA and the increasing desire of including open source software in critical systems. So first, many functional safety and security standards could be taken as example. Here I've chosen 61508 for safety and 62443 for security. So they require processes to be in place and evidence to be produced. In particular, source code analysis is part of the required evidence. So you have a rule set, you have to include the precise tool configuration and all the forensics data that ensure that you have actually analyzed the software that is built into the device. And of course, the findings of the static analysis and the deviation reports. So in this presentation, I do not separate safety integrity level and security level. For the purpose of this presentation, they are the same thing. They are qualitative measures that require proportionate rigor to ensure the capability, depending on the criticality of the functionality implemented. So Here is some highlights from 62443, in particular to part 4.1, which includes the security development lifecycle requirements. So we have the requirement of using secure coding standards and so static analysis to detect coding errors such as buffer overflows, null references, and all these kind of things. We have closed SVV3 about vulnerability testing that requires vulnerability testing typically including static analysis and also binary analysis, not just source code analysis. And then for SI1, security implementation review, the importance of reviews is very high, and source code analysis provide input for this review. Okay. Then for 61508, the part we are interested in is part 3, which deals with software. So Annex A points to the detailed technique. In Annex B, and Annex B there is B.8 that explicitly mentions static analysis, which is required for SIL 1 and highly required for the other safety integrity level. And also Annex A9 explicitly points to B8 among the techniques and measures to achieve the systematic capability. Okay, so the practical reading is that we have to apply source code analysis on all the safety-related modules, and then I have accurate and coherent documentation about the rule set, the tool configuration, the findings, and the deviation, and so on. Of course, doing all this requires tools, and so requires also confidence in the tooling and IEC 61508, as basically all other standards have a part about this. Okay, so source code analysis is, in a sense, the micro lens, so it verifies the assumption at the code level. It can find classes of defects that are often missed by other techniques, for example, missing or incomplete initialization, so the software might work, but might work by chance. For example, when you are not properly initializing a data structure. It can be used to enforce architectural constraints, so to ensure that you are not bypassing layers, or you are not having unwanted interaction between modules, and it enforces traceability. For example, code that is missing, code that is not traceable to requirements, and so on. So the integration recipe for open source. So in this talk, I'm mixing things that we have done already with things that we are in the process of doing, and with desiderata, so things that we would like to do. So one of the important things for integrating systematic static analysis into open source software is training of the key people. So to start with, all the maintainers. And then what we need is tailored guidelines, meaning, so let me talk about the MISRA coding standards. The MISRA coding standards are a compromise, okay? So MISRA C is constituted in this, in the latest version by 223 guidelines, okay? There are many of them, 223, but there could easily be 500, which we don't want, okay? So the rules are a compromise between simplicity and targeting onto actual defects, okay? So they are designed to be simple to understand, and they are more restrictive than necessary in the abstract, okay? So tailoring is an essential thing, and which is supported by MISRA. I will explain this in a minute, what it means. So it means adapting the guidelines to the particular environment. There are certain things that are not defects per se, but they are violation of MISRA guidelines, and it is possible, and MISRA explains how to do this, to tailor the rule to adapt it to the processes used in the particular project. One thing that we are working on is this yellow flag lane for justified deviation. So I will say what I'm meaning by this later. And incremental and baseline aware analysis to cut noise. So when you start in an open source project, you may start easily with, I don't know, hundreds of thousands of violations, okay? And you cannot tackle them all at once. So you need to do what is called a baseline. You can say, okay, we accept those that are in today, at least for certain guidelines, and we want not to introduce more. And meanwhile, we want to cut down on the violation to solve the backlog. There is an issue about the handling of multiple configuration. I say something about this, and of course, we need tooling that supports everything. Okay, so tailoring the MISRA guidelines. So I don't know how many in the audience are familiar with the MISRA guideline, but say that I present some simple examples. So rule 10.1 is a rule saying that you don't mix types in a dangerous or confusing way. So you are not using a Boolean to index an array. Okay, and you are not mixing signed with unsigned and so on. Okay, so and the rule covers many type mismatches, so to speak, but many of them are safe actually. Okay, so for rule 10.1 as is, you would have, for example, on the Linux kernel, you would have 20,000 violations. But given that MISRA itself says code quality always comes first, you don't want to change the code in 20,000 places because it's quite likely that you will introduce bugs. Okay, so it's better to deviate, and deviating means tailoring a rule. So, for example, all the ones that I'm not going through them, all the conditions that are in the slide, they are violation of rule 10.1, but they are safe. So the remaining part of the rule, so the important part of the rule is avoiding unspecified behavior, undefined behavior, and implementation-defined behavior. What remains is developer confusion. In certain cases, you might say, hey, there is no developer confusion here. Okay, so you may argue this. And in this case, tailoring will save a lot of time. This doesn't mean that we tailor the guideline and then we are happy with it and we don't change the code anywhere. So this is part of our experience in the Xen hypervisor. In the Xen hypervisor, they had this, and we made probably 30 or 40 weekly calls with the maintainers, and it was interesting because half of the maintainers were knowledgeable about this big trick, but the other half were not. So this is an interesting big trick that does one thing. So the Xen community decided, no, let's encapsulate this bit trick into a macro, and the documentation will say precisely what is done. And we will deviate rule 10.1 for that macro. Okay, so tailoring doesn't mean, okay, we forget about the rule. In some cases, the MISRA violation will tell us it's better if we change the code. Here is another example. There is the rule 13.1 that says that initializer list shall not contain persistent side effects. Okay, and the reason is that the ordering in which the initializers are executed, it's unspecified. So this means that the software could be unpredictable. Okay, so this is an example where MISRA decided to have a simple rule. So no, not even one persistent side effect in an initializer. But if you have only one, it's actually safe because there is only one. If you have at least two, then you don't know in which order they occur. But if you have one, so And this, in our work on the Linux kernel, turned out to be very effective. So we tailored the guideline. We say, no, we tolerate at most one side effect in a initializer. And this was extremely beneficial. Okay, so I have another example here. So there are cases where, yes, the thing in general is unsafe, but for certain compiler, it is safe. So, for example, GCC provides you with guarantees that certain operations are safe and you can exploit them, especially when you have the sort of commitment that you will use GCC. For example, the Zephyr software, the Zephyr SDK is based on GCC, so Zephyr project can use this. And another interesting case is this. So MISRA says to exclude code, you use the preprocessor. And so you use a sharp if def, a sharp if and a def, and things like that. But in the Linux tradition, they don't want to do this. So they want, to use a ordinary. Oh, sorry, no, I'm out of sync with my slides. So it's so unnatural for me to look there for the slide. Okay, so Rule 16.3 says you have to have an unconditional break statement for every switch clause. But this is unnecessarily restrictive. So you can have a goto or a return, or even you may call a function that is annotated with no return, so it will never return. This is good enough. Okay, so now in the latest version of MISRA, this became the default, but there are several projects, for example, Xen, for example, Zephyr, that use MISRA C 2012. And so this kind of tailoring is important to them. Another example is conditionally excluding code. Okay, so the MISRA compliant way is by the use of the preprocessor. Okay, so you exclude the code. The first pass of the compiler will not even see the code, and so you are done. But in the Linux tradition, they don't want to do this because they have so many configurations that chances are that when someone tries a new configuration, the code doesn't even compile because it has never been compiled before. So they prefer using ordinary ifs. Okay, so this requires another tailoring. Okay, and this, of course, and I say this especially because we have Marcel in the audience. So this places a burden in the compiler qualification. You can do this, but you have to make sure that your compiler will actually compile out a code that is guarded by if 0. Okay? So this is another example of tailoring. So about yellow flag review. So there is this problem in an open source software. How do you ensure safety without delaying the development too much? Okay? So the idea is to have an intermediate way between the green flag, looks good to me, or a red flag, no, this cannot go in for some reasons, and it's a way of dealing with patches that include acceptable MISRA violation. And the goal of this is to keep velocity of development, make the deviation explicit, and have the best of both worlds. So the outcomes of a yellow flag review may be the patch is approved with a justification of the deviation, or a request of reworking the patch to become green, or escalate to red. Okay, so how is this done in practice? In a continuous integration setting, there is a sort of a bot, of a static analysis bot that will annotate the source code involved in the change with all the information required to the maintainer and to this other figure, which we call the safety steward, to decide what to do. In particular, it is important that there are the violation details near the line of the change, and also hints about possible code correction or hints about a possible deviation, and possibly with readily available extracts of relevant documents for the maintainer and the safety steward to decide on the yellow flag. Okay, then this can be accompanied by, I don't know, service level agreement, things like, okay, the project guarantees a 72-hour for yellow review of yellow patches, and also you can have dashboard and metrics to make sure that you find the bottlenecks. So this is the meaning of the flag state. So green is the normal maintainer path. So the maintainer says, yeah, okay, so it passes all the checks that are in the CI pipeline. It's a normal maintainer path, and typically the outcome is that it is merged. And then the yellow flag means that there are deviations that still are acceptable, and the maintainer and the safety steward may approve with justification or ask for a reworking or escalate, whereas the red flag is as usual. So, and then here we may want to have other figures, so safety gatekeeper, and typically what will happen is that the patch will be rejected or a major rework will be asked. So we had some experience on this. So as Philip mentioned, we have been involved in the, we are involved today in the effort towards the qualification of the Xen hypervisor. I don't have time to say this, but in order to prepare for what I will be saying later, so let me tell you that this work has been funded by AMD, and they use the Eclair static analysis tool, which is what my company produces, in GitLab in this case. And okay, another thing that connects with what we have said before, all the maintainers were trained, so they followed a MISRA course, a full MISRA course, which lasted 1 week. Okay, and this proved to be very, very effective. Yeah, okay, this means 5 minutes. Yeah, I can do it, I think. And Zephyr real-time operating system, we also have been involved, and the integration of Eclair in their continuous integration is in progress, should happen anytime now. And this is based on GitHub, okay? And the sponsor of this work is the Linux Foundation. And then trusted firmware, they didn't want to embrace MISRA compliance, complete MISRA compliance. So they want a partial MISRA compliance for the benefit of people downstream that have to build certified product. And they use Eclair. They have their own continuous integration infrastructure, which is called OpenCI. In this case, the work was funded by Linaro, and there is an ongoing handover to ARM. So one of the problems they had and that we contributed to solve was that they analyzed many different configuration and options, so that the problem was how, and these options, they share a lot of common code. So the challenge was not to multiply the violations in the common code. So we found a solution. I don't have time to go into it. Now, last thing, this is an internal project at BUGSENG. So we are working on the MISRA compliance of a small incarnation of Linux. So we took a bold approach. So we said, let's take MISRA Compliance 2020, the official document of MISRA that says upon which condition you can claim MISRA compliance. And let's be very bold. Do we have a right of disapplying all the advisory guidelines? Let's do it, okay? Do we have the right of deviating all the guidelines that are not related to undefined behavior or unspecified behavior? So let's do it. And then let's see what we are left with. And we are left with 32 guidelines that are violated. For half of them, we know what to do, and we are doing it. And I'm going to submit a proposal of presentation for Embedded World 2026, where I hope to tell you more about this. And for the rest, they are tough. And so it's an open project. So if anyone wants to join the effort, please get in touch. Okay, conclusion. The return of investment should be obvious. So it's much better if we fix the things before we merge the code. The idea is that the community contributes the code and the reviews. The work has to be sponsored because the static analysis tools and runners, they have to be paid for. Licenses have to be bought, trainers have to be paid, and also the maintainer and the safety steward time has to be paid. And okay, of course, the assessor will package evidence for certification, and we'll do this in exchange for payment. And it's a win-win. So the sponsor reduces the risk, and the project gains quality and resources. And so what to change now? So my take, of course, is train the people, maintainers to start with, and turn static analysis from optional to a merge requirement. It's not an all or nothing. You can start with half of the MISRA guideline, for example, or the very important ones, and forget about the others for the time being. So provide a default rule set and deviation template so that developers and safety stewards will know what to do when they see violation. You have to have a small team for dealing with the yellow flags and start with an incremental baseline mode. So focus initially on not introducing more problems in the code base. And that's it.